Hello everyone, and I'm going to be showing you how to be making snow in Houdini. We're going to be using position-based dynamics for this method. Something that happens with Houdini is that there's not really too many tutorials out there that show you how to do things. I compiled myself my own research to find all the assets that I need to be making snow. I'll be glad to share it to you guys. So let's get to this quickly. So right now, I'm gonna make it from scratch, so you guys don't have to be having some specific assets to follow me. So that you can just grab this and follow me along, and we can just get started with this immediately. So I'm gonna start here with a box. So this box, I just command click it. I want to transform this up a bit. So let me get this out of the way, because this box essentially is going to be what we use to emit the snow from. So I want to put this up here, and I also want to create another box, but this box right here, we're actually going to be using for collisions, because I want to show a different an example of what the snow looks like when it collides with other objects, because something that makes snow stand out from other substances is its sticky normal nature. So let me just rotate this in 45 degrees. Right. Also doing this so it can be at a slight slant, so you can see the effect more clearly. So you should make this a bit smaller right here. All right, so pretty much right here, you want to make sure that you name what you make, because sometimes when you have a lot of nodes, you might get lost. So it's best to keep yourself organized. So I'm gonna call this snow emitter. So this tab here. Okay, so immediately what we want to do is we want to tab in a grain source. So a grain source, this is what the particles essentially come out from. So here you have your, let me go here. If you see, here you have your point separation. This is pretty much the density of your particles. But we don't want to be, the packet density, we don't want to be touching these things yet. It all depends on what you want to do, but so far let's just follow along. So after putting this grain source right here, you want to be adding a rest node. So the rest position node, I'm not really too fond of what the use for it is, but if you don't add this, your simulation is not going to function. So trust me on this. Right, so now right here we want to tab in a pop network. So essentially what a pop network is, it's pretty much like your Autodot network. It's just that you're building it here from scratch. Like if you see, if I go in here, you get the kind of like how the pop network is. Like here you have your source input. So this is what you're going to use it to emit the particles. So first, we want to turn off the guides, and we want to change the emission type to all geometry. So now here we can visualize how it's going to be. So here in the birth, we want to set it so it only emits particles in the first frame, because this is snow. It's dynamic. It's a static object, but it doesn't keep simulating like water does. So we're here that what does it is $FF equal to 1. And by typing this, you're going to make it so that when you simulate, it's only going to make particles in the first frame. So we want to probably test this out right now. So let's type in a ground plane. So this ground plane we just have here, and let's create a static solver below it. And now what we want to do is we want to merge the pop solver right here to the static solver. So let me just grab that here, create a merge node. Click this here, connect this here, and now we want to connect this one to here. Alright, so now if you click play, nothing's gonna happen, because there's no gravity applied to this. But instead of applying gravity, we're actually going to use pop force. So the pop force here, we're pretty much just going to apply a force to it. So in the y-axis, you want to put -9, kind of like the gravity is normal. But before this, also add pop grains. You want to make sure that you put this before the pop force. Okay, so pop grains, this is what makes the magic happen. This is the node that you want to, this is where all the tweaking goes, like how the snow moves, what it feels like, the density, how it sticks together. This is everywhere that you want to, this is where everything that you want to edit is. So this is what you're going to be playing around with later, but in the meantime, let's just test it over here. Let's see. Okay. So you can see it looks a little strange, because normally snow, when it falls, it sticks together. So As you can see here, it just keeps on spreading, so that's something that we have to fix. And that's fixed, and you can fix that stuff over here in the in the pop grains node. But we're going to get to that later. Okay, so now what we want to do is the particle separation here in the pop grains, you have to make sure that this value is equal to the value of the pop grains of the grain source that it's outside here. You see the point separation, which is what affects the quality of the how many particles come out. So right here, you want to make sure that you copy parameters, right click, and you go out, you click on the grain source, and over here in the point separation, you right click and paste relative references. So every time you edit, every time you edit the pop grains out here, it's going to also affect the one that's outside. So okay, I'm moving on. So what you want to add right here, something else. When you simulate this sand, it's not going to look too good because you need more substeps. So over here in the pop solver, you want to make sure that the substeps are at least at 10. So you can play around with these as much as you want. You can go over, but I do not suggest going under 10. So you can see here how it's looking. And it's giving a little bit of a separation. Alright, so now what we want to do is we want to tab in a pop sprite. So this is kind of, well, exactly what it says. It's kind of like a sprite. As you can see, that it kind of gives us this like this fuzzy look, because it plugs in a sprite to it, so that way you can add a shape to it. But what I want to do is I want to make it look like it's emitting spheres, because it's very good for visualizing as you're still working. So I click on here. Just to make sure I clicked on this button right here, and you're not always going to end up with this window because sometimes you might be in another thing. So if this window does not show up, make sure to click right here where it says $HFS Houdini /pick, and boom, you'll get this window over here. So you want to scroll down, and over here where it says sphere _ mat pick, you want to pick that, accept it, and give it a second. If I click play, you'll see that now it's actually emitting spheres. So let's see how it's looking right now. Cool, very ballsy. All right, so now we actually want to start editing the stuff that makes this look like actual snow. So we're going to go in here inside the pop grains node. A second. And now we're going to start playing around with these attributes that we have here. So one thing that I like about Houdini is that if you hover your mouse on top of these attributes right here, it actually explains to you how, like, what it does. Like right here in the friction, like with colliders, it's friction is scaled by this amount. Value of 0 will result in the particles not sticking. Okay, so there we already know what it is. So you can pretty much, like, you don't have to follow me in this part. You can literally just go and play around for yourself and start getting the results. But these are results that I actually got from actual people that worked with very, very well looking snow. So I always like to share these because I find that they're very effective. So over here in constraint iterations, you can see right here, you want to set this to 50. I'm not going to explain too much what I'm doing right here, so just follow me along and just watch the magic happen. So with colliders and with particles, you want to leave this at 1. Static threshold, you want to keep this at 0.5, but the scale kinetic, you want to put this at 2. You guys can later on read what these things do individually, so that way you have more understanding of what's going on behind this. So in the internal collisions, you want to leave the weight at 1. The stiffness, you can leave it, well, you can leave it at 10,000. Just so you can edit it if you want, but it's just all stuff you can just play around with it. So over here, the shock scaling power, this is also something that you want to lower, so you want to put this to 0.2. And finally, in the clumping, the weight, leave it as it is, and the stiffness, you want to put this to 50. So the particle separation, I'm going to put it a bit to 0.06. So it just kind of like increases the quality too much. Now, when you decrease the particle separation, be very careful, because essentially what you're doing is that it has to what Houdini does is that it's calculating the collision of each one of these particles in between each other. So every time one of these moves, it has to calculate the collision between each one of the other particles. So what this means is that you're going to have very long simulation times, not so much render times, sim times. You could be there you could be there for like 15 minutes for simulating a frame. So depending on the quality that you want to go for, I suggest not going below 0.02 unless you're going for production quality. And if you are going for production quality, then make sure that your computer can handle it, because you will crash. So let me sim this quickly. Okay, so I'm going to do a quick, I already simulated right here, just this quick part, just to show you kind of how it looks. So you see the box hit the ground and poof. But you see that unlike before, now the box, when it hits the snow, it actually sticks to the ground and doesn't slide. And you see that it actually clumps on top of each other a little bit. So that's the effect that we got from adjusting the attributes in the pop grains. So like I said, you can just play around with these and get different results depending on what you want to do. So now one final thing is, your snow should not look like balls. Like if you render this is going to look like balls. Like, not even gonna render it. No, this is exactly what it looks like. So you have to do one last step over here. Now this step right here, I'm actually going to I'm not gonna paste this node graph that I have here. It's a very simple one, but I'll explain it, because I sort of tend to get confused in this part right here. So here we got these nodes. So I'm going to explain to you what these ones do. So after the pop net, you want to tab in a point jitter. So point jitter, as you can see, it jitters the particles. I find this actually pretty cool, because it gives a lot less more of a natural feel to it, because that way it's not just all completely still, completely all the same. I guess you can use this to give some more diversity to the particles, and it gives it a really nice touch. So here's something that you can just leave however you want it. And after this, you want to tab in a point wrangle. So this point wrangle node over here, this point wrangle node, I'm not too sure what it does, but it's something that worked for me. I'm actually going to just show you this little quick thing that you have to type here. So over here, the same, you're just gonna type add p scale. Add p scale. The p scale is what? It's the size of the particles. Add p scale space asterisk equal to 1, and under that add v space asterisk equal to 1. So I'm just gonna copy, paste this here. In attributes to create, over here you want to put asterisk up 0p input asterisk again. So don't ask me what this does, but it just seems to work for me a lot of time. Now after this, you want this is a node that actually makes the effect that you're looking for. So over here, let me see how it looks. Over here, now you want to make a volume rasterize points node. Now this node right here was pretty confusing at first, because over here. So there's a specific way that you have to connect this. So right here, if you see, the input 1 has to be the base volume, and the second input has to be the points that you to rasterize. So the points to rasterize, it's in the node that you created. So the node graph right here, you connect this here. If you connect it elsewhere, it's not going to function. And over here, the base volume, you actually have to tab in something called a VDB, just like that. And over here, you want to connect this. You pre-visualize it, but right now you can't see anything. You actually can, but as you see right there, the balls that we used to have, they actually turn into a volume. So the point rasterize volume, as it does, is it grabs all the points that it has there, and it kind of joins them in together to give it a different shape. So that's why I'm saying that. This is the best way to remove the ball effect. So right here, the only thing that you have to do is you just have to decrease the voxel size from 0.1 to 0.01, and this will make the snow a lot more. It puts the particles like that. Now, of course, it looks like this because I have a very low resolution. So I can simply just go to my pop net. Here is it. Here it is. Go into my pop nets, and over here in my pop grains, I can increase the particles of creation from 0.06 to 0.04. I don't want to get too crazy because, you know. And now finally, we're finally going to put that box that we made in the start to good use. So I can just sim this, and you can just see how it looks like. But nah, it's gonna take too long. So first things first. Like I said, this box is just mirror for collisions. So the ground plane is already there, and I'm just gonna add another ground plane here. That here. Bodies, ground plane. Awesome. I'm gonna grab this box and click static object. Make this a static object, and that's it. Something cool is that when you, whenever you make a node network using the popnet, instead of adding these attributes that you just connected to a new pop network, if you can see right here, it did not create an auto dot network. It actually connects all inside the pop network. So you see right here, it keeps everything local, which is also a really cool thing that I see it does. So actually, I don't even need this second ground plane because I already have one. All right. Right here, essentially, I'm just going to simulate this, and you guys will see how the sim looks. All right. So I quickly sim this right here just to show you guys how the overall look is. I put it again in like a little box because I find it much better to pre-visualize when it's in this mode. So now as you see, if I click play right here, it actually, you can see how the particles, they actually go down, and you have some that stick up in the top, while you have the rest that kind of just like start dripping. And that's really how snow actually like functions. And I find it really cool that this method it's pretty quick and simple to set up, and it's very intuitive. Like there's a lot of stuff that if you don't like it, like, you can change it yourself. Like all you have to do is just go to the emitter, go to the pop net, and over here you have everything. Like even for the rendering part, after you created the volume rasterized node, if there's anything that looks strange, like you might not always get the snow type that you want, you can go in this and just like start playing around with these settings, like the FOV, placement, tech noise, like all these things you can just play around with. This is precisely why I like it so much. It gives you a lot of creative freedom with it. I definitely recommend that. Aside from this video, you also play around with it more on yourself in your own time. But yeah, that's pretty much it. I'm actually going to show you guys I'm actually going to show you guys a quick simulation that I did right here. I actually did this today, following the same exact method that I just taught you guys. So you can see you can definitely play around a lot. Like all you have to do is just build whatever you want from it. It's very fun to do it. So I hope you guys found this video useful. I hope you had a lot of fun with it. If any questions that you have, you guys can just send me a comment, and I'll be sure to reply as soon as I can. But have a good one.